Level 0. The pop. It's the sound of childhood, a balloon bursting in your hand, a soda can dropped just wrong, a party popper flaring with a flash and a squeal. There's pressure, yes. There's even a release of energy, but it's contained, harmless, annoying, maybe startling, but only because it catches you off guard. No flame, no flash, just a membrane giving up, all at once. You don't feel fear, you feel surprised, the kind that makes you flinch, blink, maybe laugh afterward. It's physics, not firepower, a differential in pressure that wants equilibrium and finds it with a bang. Pop rocks, cap guns, snapping plastic, all fall here. In terms of force, you're looking at a few joules. It's a conversation between air and elasticity. The worst that might happen? A ringing ear, a moment of panic, maybe a small welt if it explodes too close. This is the level where explosion exists in form but not in consequence. An acoustic punctuation mark, a prelude to what real pressure can do. Why does a balloon pop so loudly? When you puncture stretched rubber, it snaps back faster than the speed of sound, compressing air and releasing a micro shockwave. It's a miniature sonic boom. No flame required, just stress, release, and a little bit of chaos. Level 1. The chemical snap. Now it's not just sound, it's a reaction. You drop Mentos into a 2-liter bottle of soda. A foam geyser erupts, pressure forcing its way out, flinging sugar syrup skyward like a rocket blast in reverse. Still not on fire, but now you're watching chemistry imitate combustion. Think vinegar and baking soda, hydrogen bubbles lit with a match, a magnesium ribbon curling into white flame. The scale is still small, the kind of thing you'd see in a school lab or a backyard science show, but the behavior is suddenly energetic. This isn't a bang from a weak shell, it's a chemical push, a reaction that builds, then bursts. A soda bottle rocket climbs 30 feet into the sky. A sealed Ziploc, loaded with dry ice, swells until it finally gives, rupturing with a boom that rattles windows. You're still safe, mostly. But get too close, and that burst of gas can scald. Get careless with the mixture, and now you've got flying shards of plastic. Explosions don't require flame, they require energy leaving too fast. And now you're learning what that looks like. Ever shaken a soda can? The fizz isn't random. CO2 is dissolved under pressure. Shake it, and you nucleate bubbles. You're forcing gas to find space it doesn't have, so it pushes out violently the moment it's allowed. That sudden release is mechanical detonation in miniature. Level 2. The combustive bang. Now we light a match. This is the point where fire joins pressure, where chemistry turns volatile. Gunpowder, gasoline, propane. Now you're playing with real combustion, and the damage starts to feel real. A firecracker in your hand can burn you. In your face, blind you. You light a gas stove and forget the pilot. The kitchen flashes with a whoosh. Now your eyebrows are gone, and your heart beats in your throat. At this level, the energy isn't just chemical, it's thermal. You feel the heat on your skin. The sound doesn't just startle, it vibrates your ribs. You can be thrown backward. You can lose hearing. A single spark in a propane-filled room, and your walls don't just rattle, they breathe, outward then inward in a cough of flame. This is where fireworks live. But so does gasoline vapor, and when it ignites in a garage or under a car hood, the effect isn't a flash, it's a whomp, a force that can tear open doors and launch debris. It's still survivable, but it's also a turning point. After this, explosions don't ask permission. They command respect. Fireworks get their color from metals. Copper burns blue, strontium burns red, barium burns green. Each pop of light in the sky? It's an elemental signature, a chemistry lesson turned sky art. But behind the beauty is black powder. Potassium nitrate, sulfur, and charcoal, burning at 2000 degrees Fahrenheit in milliseconds. Level 3. The structural shatter. Now the blast has a job. Tear things apart. This is where explosions are no longer theatrical, they're functional and destructive. A gas line rupture, a mining charge, a confined chemical blast in a pressure vessel. These aren't recreational, they're engineered for results. And those results? Concrete reduced to dust, steel peeled like banana skin, brick torn into powder and wind. You're now dealing with shock waves in the 2 to 5 psi range, enough to knock people flat, tear lungs, and shatter windows 100 feet away. The noise isn't just sound, it's pressure. It hits your body like a shove. Ears ring for hours, heads spin. In controlled environments, like building demolitions, it's a science. Placement, timing, sequencing. Engineers time charges to make concrete fall inward, floor by floor. One charge too early, and the whole thing becomes chaos. One too late, and it becomes a sideways hurricane of rubble. But in the wild, gas explosions in kitchens, underground methane ignitions in mines, one spark in the wrong duct, and a whole block gets reshaped in a second. This is no longer just fire, it's force, measured in atmospheres, delivered in microseconds. You can survive a structural blast if you understand blast waves. The overpressure can rupture eardrums at just 5 psi. It can collapse lungs at 15, but a single foot of concrete can reduce those forces drastically. In a blast, don't run toward exits, find cover. Solid mass saves lives, windows do not. Level 4. The tactical explosive. At this point, the explosion isn't just damaging, it's weaponized. Now you're looking at devices designed to kill, not collapse. Grenades, claymores, shaped charges. These aren't just about pressure, they're about fragmentation, direction intent. A frag grenade doesn't just explode, it detonates inward and then projects outward. The steel shell becomes shrapnel, thousands of tiny bullets flying in all directions at supersonic speeds. The kill radius? About 5 meters, but fragments can travel 200. Hiding behind a tree won't save you. If you're not behind hard cover, you're exposed. Shaped charges take it even further. Copper cones collapse into a focused jet that can slice through 2 feet of armor. It doesn't blow up around the target, it blows up through it. In war, this is the language of breaching, of disabling vehicles, of clearing rooms. C4, RDX, PETN. These aren't just energetic materials, they're precise. Controlled, they're surgical. Uncontrolled, catastrophic. The noise, deafening. The flame, blinding. The shock, like being hit by an invisible freight train. No time to react, no chance to flinch. It's not just destruction, it's deliberate, directed annihilation. The front toward enemy label on a claymore mine isn't a joke. It fires 700 steel balls in a 60-degree arc. In milliseconds, it can sweep a field clean. If you're within range and upright, you don't get hurt, you get deleted. Rule of survival? Distance and direction matter. Level 5. The Vehicular Vaporization. This is when explosions stop being events and become scenes. Think, a fuel truck engulfed in flame, a missile strike on a convoy, a car bomb erupting in a crowded square. One moment, metal and motion. The next, a blooming fireball taller than buildings, and a shockwave that sets off every car alarm for blocks. The sound hits after the sight. The flash whites out your vision. Then the pressure slams into your chest, a physical thud, like your ribs forgot how to move. At this level, explosions don't just break things, they erase them. Shatterproof glass melts, tires become vapor, metal is twisted into scorched spaghetti, limbs, lives, architecture, all become collateral. The fireball isn't just flame, it's fuel, gasoline or diesel, aerosolized and ignited, a combustion cloud expanding at over 3,000 feet per second. In closed spaces, like tunnels or city streets, the blast rebounds, intensifying itself. Thermobaric weapons take it further. They disperse fuel into the air, then detonate. The result? A pressure wave that lasts longer, hits harder, and consumes the oxygen in the area, flash cooking everything inside. This is where safety distance means half a city block, where survivability isn't just about dodging fire, it's about escaping the air. Thermobaric explosions don't kill you with fire, they kill you by sucking the air out of your lungs, then igniting it. The first blast ruptures your organs, the second cooks them. That's why soldiers fear them more than shrapnel, because there's nowhere to hide from a vacuum followed by flame. Level 6. The Fuel Air Nightmare. This isn't just fire and pressure, this is engineering turned apocalyptic. A fuel air explosion or thermobaric blast doesn't just detonate, it inhales. Step 1. Dispersion. A cloud of aerosolized fuel sprays into the air like an invisible mist, covering a wide area. Step 2. Ignition. A second blast ignites that mist, turning the entire oxygen-rich environment into a shockwave amplifier. What follows isn't just an explosion, it's a vacuum and a firestorm rolled into one. The shockwave lasts longer, burns hotter, and sucks the air from every nearby lung. Victims don't just die from heat or pressure, they suffocate mid-step. Lungs collapsed from the sheer force of the blast wave. Buildings are shredded. Reinforced bunkers, crushed, human tissue, pulverized by internal hemorrhaging. These weapons are sometimes called vacuum bombs, not because they create a void in space, but because they create one in your chest. The Soviets pioneered them. The US perfected them. They've been used in caves, cities, and battlefields. A single device can flatten a block, not with fire, but with physics. This is what happens when chemistry marries strategy, and it's not banned, not completely, not under international law. How to survive. If you're near a suspected thermobaric strike zone, get underground and seal your space. These weapons consume oxygen, so any chance to insulate yourself from atmospheric mixing could save your life. Standard shelters won't do. You need depth, reinforced ventilation systems, and airtight seals. You're not escaping the blast. You're trying to survive what comes after, the air itself turning on you. Level 7. The City Killer. There's no sugarcoating this one. This is Hiroshima. Nagasaki. The Mushroom Cloud. Nuclear weapons redefine the concept of an explosion, because what detonates here isn't just chemicals, it's atoms. A fission bomb like the one dropped on Hiroshima released the energy equivalent of 15,000 tons of TNT, a fireball hotter than the surface of the sun, a shockwave moving faster than sound, radiation penetrating walls, windows, skin. The initial blast alone kills tens of thousands, but it doesn't stop there. The heat ignites fires across the city. Survivors stumble through ruins, blinded by flash burns, clothes vaporized, shadows etched onto pavement. Hours later, radiation sickness sets in. Vomiting, hair loss, bleeding, bone marrow collapsing, and then fallout. Wind picks up radioactive dust, carries it across continents, contaminates soil, water, everything. This is the moment history split. Humanity learned that we had the power to unmake ourselves. How to prepare? You can't outrun a nuclear explosion, but you can survive one if you're far enough. Experts advise: get inside, stay tuned. Concrete buildings protect best. Head to a basement or interior room. Wait 24 to 48 hours before emerging. Fallout decays fast. Most casualties in nuclear events come not from the blast itself, but from panic, poor sheltering, or ignorance of fallout patterns. Knowledge isn't just power, it's survival. Level 8, the Thermonuclear Era. If Level 7 was hell, this is the next circle down. The hydrogen bomb, or thermonuclear weapon, is not just more powerful than the atomic bomb. It's in a different universe. While fission bombs split atoms, fusion bombs merge them. A small atomic bomb acts as the trigger. It creates enough heat to spark nuclear fusion, the same process that powers the sun. The result? A single warhead can unleash energy equivalent to 10 million tons of TNT. That's not a city killer, that's a region eraser. Take Tsar Bomba. Detonated by the Soviet Union in 1961, it was the largest nuclear explosion ever created. 50 megatons, windows shattered 900 kilometers away. The shockwave circled the Earth 3 times. The fireball itself was 8 times taller than Mount Everest. If used in war, a thermonuclear weapon doesn't just destroy a place, it ends it. All structures, all life, all systems, gone, reduced to ash, heat, and radioactive silence. If this sounds unthinkable, it is. That's why we haven't used them again. Yet. In the event of a nuclear crisis, radiation preparedness is essential. Build a go bag, iodine tablets to block radioactive iodine, sealed water, and radios. Learn to identify wind patterns for fallout direction. If a detonation occurs, your chances of survival increase tenfold just by sheltering properly and avoiding exposure for the first 72 hours. After that, radiation drops significantly. You can't stop a thermonuclear bomb, but you can outlast its reach. Level 9. The Planetary Scar. Now we leave the realm of man-made explosions and enter cosmic ones. This is the asteroid impact level. Picture it, a rock 10 kilometers wide enters Earth's atmosphere at 70,000 kilometers per hour. Friction turns it into a fireball. When it hits, it doesn't just create a crater, it creates a caldera of extinction. This is what ended the reign of the dinosaurs. Not just the impact, but what followed. Firestorms across continents, mega tsunamis hundreds of meters high, atmospheric soot that blocked sunlight for months. Photosynthesis stops. Food chains collapse. Temperatures plummet. This is an explosion that breaks the biosphere. The energy released? Estimated at over 100 million megatons. That's 2 million Tsar bombers at once. Even if you're on the other side of the planet, you're not safe. The entire planet shakes. Air becomes poison. Sunlight dims. Crops fail. This is a level of destruction we can't engineer. We can only anticipate and hope to prevent. So what can we do? Believe it or not, we've made progress. NASA's DART mission proved we can nudge asteroids off course. The key is time. Years of lead time are needed to detect, predict, and deflect an incoming object. Supporting space programs isn't about science fiction anymore, it's about Earth's insurance policy. Level 10, we've now entered theory, because no explosion at this level has ever been witnessed, and hopefully never will be. This is the realm of exotic physics, hypothetical weapons, cosmic scale destruction. One scenario, a doomsday device using antimatter. Just 1 gram of antimatter could produce an explosion equivalent to 43 kilotons of TNT. A kilogram, the yield of a large nuclear bomb, with zero fallout, just pure energy release. Another, a theoretical quark bomb, which, if possible, could initiate a chain reaction that turns all matter into strange quarks, collapsing Earth into a dense lump in microseconds. A literal planet-ending event. Or worse still, a false vacuum collapse. The idea that our universe is in a metastable energy state, and a sufficiently powerful explosion could trigger a transition to a lower energy state. The result? Physics itself rewrites. The speed of light changes, chemistry stops working, galaxies vanish. These aren't explosions in the conventional sense, they're existential threats baked into the laws of nature. Too wild? Maybe, but we didn't think atoms could explode either, until they did. So what can we take away? Level 10 is cautionary. It reminds us of the power we wield and the responsibility that comes with it. Theoretical physics is not just about discovery, it's about boundaries, and learning not to cross them without understanding the stakes. The best value here? Education. A world full of scientifically literate people is a world less likely to stumble into annihilation by accident. Let's be clear, explosions aren't just fire and noise. They're a language of energy, of consequence, of history and hubris. From harmless pops to global extinction events, each level shows us what happens when pressure meets release, when nature or humanity says, enough. And whether you're dodging fireworks or designing bunkers, one truth stays constant. The more we understand about explosions, the better chance we have of surviving them. Thanks for watching. See you in the next video.